Functions are the first block of organization in our program. So, writing them well is crucial. Let's discuss the best practices to write clean functions, as mentioned in the book Clean Code. So, what's make the functions easy to read and easy to understand? How can we write functions that communicate their intent? Well, the first rule is that the functions should be small. Now, you can ask how we can measure that a function is small or not. Well, we can measure it by the number of lines, and ideally, a function should not be more than 2 or 3 lines. And to make that possible, we will have to ensure that the blocks within the if statements, else statements, loop, and all that should be only 1 line long. And probably that line should be a function call. Why small? Because small functions are easy to read and easy to understand. The next point is that functions should do one thing. That sounds obvious to some people. And we often hear the people saying that functions should do one thing, they should do it well, they should do it only. But the problem is, how can we determine that a function is doing only one thing or it is doing more than one thing? So, on that, Robert Martin says that if a function does only those steps that are one level below the stated name of the function, then the function is doing one thing. After all, the reason we write functions is to decompose a larger concept into a set of steps at the next level of abstraction. So there should not be sections within the functions. And in order to make sure our functions are doing only one thing, we need to make sure that the statements within our functions are all at the same level of abstraction. That is what we call the one level of abstractions per function. How can we ensure that? So, there's one trick for that. One should be able to read the code in a top down narrative. That is what Robert Martin called the step down rule. So, put it in a different way, his argument is that we want to be able to read the program as though it were a set of two paragraphs, each of which is describing the current level of abstraction and referencing subsequent two paragraphs at the next level down. For example, something like this. To include the setups and teardowns, we include setups, then we include the test page content, and then we include the teardowns. To include the setups, we include the suite setup. If this is a suite, then we include the regular setup. To do this, we did that, and so on and so forth. I mean, one should be able to read his function like a paragraph, starting with to. To do this, we did that. This is something that take a good amount of time to practice, but it's a very useful trick to ensure that your functions are small and doing one thing at a time, one level of abstraction per function. Next point is about the switch statements, the most common statements that we put inside our functions. And these statements are a big hurdle in writing the clean and small functions. Why? Because the problem with the switch statements is that it is hard to make a small switch statement. Even if you have only two cases, then your switch statement will be longer than a single line block of if and loop. And on top of that, it is also hard to make a switch statement that does one thing. By its very nature, switch statements always do n number of things: case X, case Y, case Z, and so on. And unfortunately, we can't avoid it. We'll have to put the switch statement inside our functions. Sometimes the logic demands that. So the solution is that we use the switch statements only to create polymorphic objects and put that inside an abstract factory, a class that is responsible to call the subclass objects. The factory class can use the switch statement to create appropriate objects of the derivatives of superclass and then calling the appropriate functions. So, the whole argument which Robert Martin is trying to make here is that one must avoid the switch statements inside a function. Even if you have to put it, use it to create the polymorphic objects, like in the case of the factory class patterns. But despite being aware of the fact that switch statements are going to make our code lengthy, sometimes we have to apply them for the sake of some logic, and we cannot simply avoid doing that. The next point is use descriptive names. A function name should describe its purpose, and we must not be afraid to make a name long. A long descriptive name is better than a short enigmatic name. That's the whole point which Robert Martin is making here. A long descriptive name is better than a long descriptive comment. So use a naming convention that allow multiple words to be easily read in the function names and then make use of those multiple words to give the function a name that says what it does. We generally use either the verb or the verb phrases in the function names. Choosing descriptive names will clarify the design of the module in your mind. Sometimes using a descriptive name help us to think more about our design as well. We have seen people restructuring the whole code after giving some thought on the name of the functions. Because when you think about what your function is actually doing, then you get more clarity about the overall larger design of your module and the whole purpose of your program, your system that you are building. And finally, one must consistent in using the names. Use the same phrases, nouns, and verbs in the function names as you choose for your modules. There must be some consistency in the naming convention that you have formulated for your specific cases. And never ever repeat yourself. Remember the dry principle. Do not repeat yourself. The duplication of code is a big problem because it bloats the code and create a mess. Many of our principles and practices are designed to solve the duplication problem. So while dealing with functions, with the intent to write the clean and understandable functions, one must always remember that the functions that you are building should be small. They should do only one thing, one level of abstraction per function. That's the arrangement. That's how the arrangement of your function should look like. Avoid the switch statements, and even if you have to include them, use them to delegate the task of creating the objects, like in the case of factory patterns or abstract factory patterns, and use more descriptive names for your functions. And finally, always remember the dry rule. Do not repeat yourself. Duplication is a mess that must be avoided. So, this is all we have for the functions, for the arrangement of the functions, for the blocks within the function, and for the other outer aspects of a function. But there is an important aspect related to function as well. That is, they contain the arguments. After all, the whole purpose of a function is to pass argument or to return argument. So, what kind of arguments one should put inside the functions? What are the best practices while declaring the arguments inside a function? What are the ways to write the clean arguments of a function? We'll discuss all that in the next part.